When we solve for the zero input response, we need to specify the initial conditions. Typically, we specify these at time 0, but this can cause some problems if we're not careful. The purpose of this presentation is to clarify the issues regarding when we specify the initial conditions. Now first recall that the total response is the sum of the zero input response and the zero state response. The zero input response is the response of the system when the input is 0. It's the response to the initial conditions. And the zero state response is the response when the initial conditions are 0. It's the response to the input. Now in a typical problem, the input is a causal signal. It doesn't start till time 0. And the system is usually causal as well. As a result, the zero state response is a causal signal. That is, it starts at time 0. We know that a causal system will always have a causal output if the input is causal. Now, if the initial conditions are really going to be initial, they have to have these values before any change occurs. Now, the input will cause a change at time t equals 0, and so we need to think carefully about these initial conditions. They need to happen before time t equals 0, and therefore we'll specify our initial conditions at right before this time, a time we call 0 minus, just before the input may change things. So the initial conditions are specified at time 0 minus, and then the response to the initial conditions, the zero input response, proceeds from there. This is shown in the top graph. The zero state response is a response to the input, and if the input is a causal signal, the zero state response will not start until time t equals 0. The total response is the sum of these two signals. Now what I want you to notice from this graph is that the total response can be discontinuous. This is because the zero state response can be discontinuous at time 0. And as a result, y at time 0 plus may be quite different than y at time 0 minus. Y at time 0 minus is only due to the zero input response, and that is the initial condition. So, y just a little bit after time 0 may not be the same as the initial condition. The reason? Because the zero state response has caused a discontinuous change in the value of y. What is the output y at time 0 minus? Well, let's recall what y is. Y is the total response. It's the sum of the zero input response, which we label y0, which is the response to the initial conditions, and the zero state response, which is the response to the input. At time t equals 0 minus, the zero state response will be 0, since we have a causal system with a causal input signal. And therefore, the total response at time 0 minus will be equal to the zero input response at time 0 minus. That is, it will be equal to the initial condition. And the same will be true for all the derivatives of the total response. They will be equal to the initial condition values for the derivatives. We have seen that the total response can be discontinuous between slightly before 0 in time and slightly after. But the characteristic modes are continuous functions of time, and there's only an infinitesimal difference in time between time 0 minus and time 0 plus. So we know the zero input response and its derivatives must be continuous from time 0 minus to time 0 plus. I want to emphasize, though, that the total response may be discontinuous from time 0 minus to time 0 plus, even though the zero input response is continuous. The reason why is the zero state response. It may be responding to an input occurring at time 0, and its response may be discontinuous.